Let's kick off. As I said, it's the last session. I'm trying to remember the letter. I think it's the letter R for Robert, 5R. And we've got Ezra here again from across the pond, who's going to give us an hour on the delights of CPSM. So Ezra, please take it away.
Thank you, Rob. So I'm just showing my face for a minute to show that there's actually someone live here. I'm not some AI bot or something. Yeah. So, but then I like to save the bandwidth just in case something goes wrong. So let me share my screen again. Okay. Again, for those that didn't come to the last one, my name is Israel Gross. I'm a Principal Solutions Advisor at Rocket Software. And today I'm going to talk about a CICSPlex SM minimalist approach, right? I think over the years, probably many people have implemented CICSPlex SM. Some have, some haven't, right? Even though it's a minimalist approach, it's going to have a lot of discussion on many of the different features and a specific talk on the ones that I mostly use, right? And the idea behind setting up a CICSPlex has a lot of value today in the fact that, you know, whether you're using the Explorer or some of the other interfaces, even the VS Code plugin for Kix works at the CICSPlex SM level, right? So if you want to be able to view all your regions in your environment, and maybe not all of them, but certainly broken up into individual CICSPlexes, it's convenient to set up a CICSPlex, even if you're not using some of the facilities within CICSPlex SM itself. Now, many of the features, as we're going to talk about in CICSPlex SM, a lot of customers don't use, but some of the features, certainly workload management, is quite heavily used in the CICSPlex environment. So this is what I hope to accomplish within the next hour or so, which is a lot, but we'll see how far we can get as quickly as we can get it. So I'm going to introduce CICSPlex SM, talk about the environment, what are the individual pieces that make up a CICSPlex, right? And so we're going to talk about things like CMASs and MASs and WUIs, right? And then I'm going to take you through the steps of installing and configuring a CICSPlex. It's relatively easy to do. The last time I did it from start to finish, it literally probably took me 45 minutes, right? And I hopefully gave you the instructions within the presentation, where to find the different pieces, what you need to do. And then what we're going to do after we do that installation is talk about the individual features, right? So the idea is single system image, so you can control multiple CIC regions from one location, either the web user interface, as we'll discuss a bit, or the Kix Explorer, and a single point of control. But from a Kix operational standpoint, you're going to see this is like what I like to use the term super CEMT or super CETA. And the only thing that makes it super is you can actually do it across multiple regions at the same time. Then I'll talk about the different CICSPlex SM components, the things that you can do with CICSPlex, like workload management, right? Dynamic routing. And then, of course, workload management is where I spend most of my time because most people run that, but don't tend to run necessarily everything else. So I have it under everything else. We'll talk a little bit about real-time analysis and monitoring, although most customers run an external monitor, and so it's probably more work than it's worth. However, there's some basic features in RTA that you can use just to tell you whether or not a Kix region is up or down. You have BAS, right, which allows you to use Kix resource definitions and keep them in the CICSPlex SM environment rather than the Kix CSD environment. And then I'll finish it up with some of the interfaces like using batch rep, a little bit about the WUI and the Explorer. And even though I have the demos usually set at the end, I'll probably just do it throughout the presentation. So that's my plan. So CICSPlex SM was originally a separate product. IBM eventually acquired it and then over time integrated it into Kix itself, so that when you install Kix, you actually get CICSPlex SM. And the idea is it's a system management tool that'll give you a single system image of your Kix regions, and you can use it to do things like workload management and use some of the newer things like platforms, applications, and policies within Kix if you're using any of that. So in an environment itself, so this is a CICSPlex SM environment, you have a couple of regions if you look at the lowest level. They're called MAS MAS is, right? So a CICS region is a MAS. It's a managed application system. And that is just the CICSPlex SM terminology for a CICS region. The terminology that CICSPlex SM uses is different than the CICS terminology because originally it was a separate product owned by a separate company. And so a lot of those names stuck, and the documentation refers to a CICS region as a MAS. So you'll notice within the CICS region itself to run CICSPlex SM, the most you need is this agent code running. You'll see a bunch of CO transactions running in your environment if you're running CICSPlex SM and you're attached to a CICSPlex. But in each LPAR, we'll also have a CMAS, which is basically a controlling address space. It's the one that's going to issue the commands to your CICS regions, get the results back, and report it to you. Now, to talk to CICSPlex SM, you need a user interface. So IBM decided to use a CICS region for that. So we call it the web user interface or the WUI server region. It is really just a plain old CICS region with CICS web support enabled for transmission of HTML pages to and from your browser for communication. It is also what the CICS Explorer will connect up to, right? So the CICS Explorer will connect to the WUI region as well. And it's a standalone region. You can reuse a region for it. You don't need as many as IBM claim, which is, one for every CMAS, unless you want to make sure you're absolutely redundant through your environment. I usually have a couple of them. If I have 15 LPARs, I'll probably have, one for every 3 or 4 LPARs. I'll have a WUI, which is connected locally to the local CMAS. There's also this concept of an ESSSS, which we'll discuss in just a second. It's nothing you set up. It's CICSPlex SM setting up an address space, and you'll see it's used for communication, especially if the CMAS is down. So this is a description of those individual items. Again, the MAS is just a CICS region. The CMAS is the controlling region. It talks to the agents, which are CO transactions, which you'll see in your CICS regions. And the WUI is really for communication to the CMAS. So the ESSSS is what provides XM and data space services. So cross memory and database services, right? To the CMAS itself. The idea being that if the CMAS were to go down, workload management would still run because the communication occurs through this ESSSS, and it has the ability to do the same cross memory. And so most of the running functionality goes through this ESSSS, which is automatically started for you when the CMAS first starts up. But if the CMAS recycles, it will still stay up and running. So to get started, what would you need to do? You have to create a CMAS, right, which is a kind of doctored CICS region. You have to have a WUI, which is really just a CICS region with a bunch of stuff in it, but it looks more like CICS than a CMAS. And you could pick an existing region or create a new one. You have to import the menus and views that you want to use within the web user interface. You have to build the CICSPlex topology, right, which is a CICSPlex definition, which is an 8-character name to reference the regions that are managed within that CICSPlex. And then you have to make these system definitions within CICSPlex SM. So it's not enough to define the CICS region itself. Within CICSPlex, you need records to say, these are the regions that I'm looking at. Then you have to modify your CICS regions to connect to the CICSPlex, which is not that difficult to do. You'd have to build additional CMASs if you have multiple LPARs, because you can only run, you have to run a separate CMAS for each LPAR that has CICS regions on it, because it uses cross-memory services for communication. And then if you want to control multiple regions across LPARs, then you have to have connections between the CMASs. Now, it looks like a lot, but it's really not that hard to do. It's not that much work to get started. So let's start by talking about creating a CMAS. So to create a CMAS, right, you can find some sample JCL. I'm going to show you where in just a second. But what makes the CMAS different than a CICS region is in its SIT, it has CPSM con equals CMAS, which is a overridable SIT parameter. It needs its own unique sysident. Then you'll notice on the right-hand side, you still need a CSD for your KICS definitions, and you're going to see something called an EYU DREP, data repository, for the CICSPlex SM definitions. So it's like the CSD for CPSM. Now, everything in CPSM starts EYU, not DFH, so you can tell the difference, right? But it's just really a customized KICS region that is meant to control other KICS regions, right? Now, we're going to see that there's an EYU PARM, right? Which is basically the name of the CMAS, and then security equal yes, or sec yes is required if any of the regions that connect to it have security turned on. Otherwise, it won't allow it to connect. So you have to decide whether you're going to run with security or without security, and it's an all or nothing thing. So again, the CMAS is just a customized KICS region. We've already mentioned the SIT parameters, and then these are the notes. Sec yes in the CMAS will require security in the MAS to connect to it, right? So here it is, samples in the library SDFH inst EYU CMSOP, which has the sample EYU parm, which you saw was relatively simple anyway, and then a sample startup procedure for the CMAS itself. So before you get started with a CMAS, you have to build its data repository. So IBM provides this facility called EYU9XDUT, which will create the EYU DREP, or data repository, for the CMAS. But this data repository define cluster and initialization over here, right, is really all about creating the EYU DREP specifically for this new CMAS. What you're seeing down here is a little bit of extra that IBM created that allows you to create your first CICSPlex definition specifically for your WUI. And this is like the old chicken and egg problem, right? Which comes first, the chicken or the egg, right? But effectively, in order to create a WUI, it has to be able to connect to a CICSPlex, but you can't create a CICSPlex without a WUI. So you got a catch-22 here. So as part of running this job, IBM added a step that allows you to create the WUI Plex name, which could be different from your Plex, the WUI name itself, the Apple ID, and its sys ID. And once this is inside the EYU DREP, that means that when you create the WUI, it can connect to its own CMAS managed by that its own CICSPlex managed by that CMAS. So here's some sample JCL to start a CMAS. It doesn't run the same program as a KICS program will, DFH SIP. It runs EYU 9 because everything starts EYU, and then they love the number 9 for some reason. XECS, which eventually gives control to DFH SIP anyway, right, after it does some initialization. So once you do that and you start the CMAS, you're up and running. So it's basically one job. They give you sample JCL. How hard can it be to do? It's very easy to get a CMAS up and running. But now you got to be able to talk to it, because in order to make all the definitions for everything else, you'll need a WUI. So to create a WUI, you start out by taking any KICS region that already exists, or you take some sample JCL to create a KICS region. Now, it's going to need a CSD because it's a KICS region. It's going to use an EYU rep, right, which is the web repository. And that's going to create or contain the HTML pages that you can use in the WUI to play with the CICSPlex SM system itself. You'll notice it needs an EYU parm. Within the parm, we're going to show you what it has. And you can see the CPSM con equal WUI instead of CMAS this time. And then you can also use init parms if you want to as well. It needs TCP/IP because it communicates through KICS web support. So here are the notes that go along with it. So you can see that you need the definitions that come within DFH list. There it is, CPSM con WUI init parm. This is just setting up for English language support. And then you need TCP/IP equal yes. So when you create the WUI server JCL has to have a couple of DDs. And some of them are optional right at the bottom. So Again, you're going to see if you want to provide user help within the WUI itself, you can add a data set under DFH HTML, and then you can use transient data import, data set to import views or export views, but you don't need transient data anymore to do it. You can actually put the full data set name in when you import it. So I actually don't provide these optional parameters anymore. But what you do need is the EYU WUI initialization parameters to get started. You need a web repository for the HTML screens that you want to look at. And then the WUI maintains its own CICSPlex SM log. So when you create the WUI, it has that EYU WUI repository that also has how the system is going to run. So when you start out, you can use the default over on the left-hand side, which means you start with the EYU start menu, which is easy. You can also modify the menus and you can customize the WUI, although a lot of people don't do that anymore. You have to specify the TCP/IP host name to connect to the mainframe, and then a port for TCP/IP, that's for the WUI, and a CMCI port if you want to connect the Explorer. And then you could set up a default CMAS context, a context and scope, which I'll talk about a little bit later on. And that's how you control what you're looking at when you're using CPSM. And then here's an inactive timeout, for example, for timing out a user connecting to it. Over on the right-hand side is just some examples of, you can change the color if you wanted to. You can put in your own navigation menu, stuff like that. It's up to you how you want to customize it. So even if you get the region up and running, the first thing you have to do is load the current screens that you want it to use. And even if you're upgrading, the first thing you do, if you ever notice, if you have a CMAS and WUI, that's the first thing you upgrade when you upgrade your CICS environment, right? Because only current level CMAS can talk to a region at the current or lower level. So if you want to migrate to version 6.1 and you're running 5.6, the first regions you upgrade are the CMAS and WUI. So you might be importing new views based on the newer releases as time goes on. So normally you do this with a COVC transaction running in CICS. And when you run COVC, and you can import directly from a data set, which is why I don't use the transient data destinations anymore. You put in the input data set name here that contains the views, and it comes in a data set called SEYU view. If you're doing it in English, then you want to use EYU EA asterisk, right? You want to specify the type of all, and you want to do an overwrite, but just be careful if you've modified any of these views, you'll lose your modifications. Keep in mind it's EYU EA asterisk, not EYU asterisk. If you accidentally import the views EYU asterisk, everything on your screen will show up as Japanese, which is hard to read unless you know Japanese. So setting up the WUI is relatively simple as well. It's just starting another region. He gives you sample JCL. You need the EYU PARM data set, you need the default settings, and then you have to import the views. But once you've done that, you're pretty much up and running. You have a WUI, you have a CMAS, and when you go to look at it, there ain't nothing in it. So you have to define the environment. The first thing you have to do is set up a CICSPlex. Now, I'm using WUI screens here. You can also use the CICS Explorer to set this up. A CICSPlex SM definition is very, very simple, right? It basically is an 8-character name. It sets up a monitor interval. I usually set it to 60 minutes. The default is like 8 hours, 480 minutes. And that will keep a lot of data. And if you're not using monitoring, it probably won't make much of a difference anyway for you. You might want to set up the time zone and the time zone offset, right? That kind of stuff. There is some stuff for CICSPlex optimized workload management there at the bottom. But if you're starting out, you define one of these CICSPlexes and you're off and running. Just be careful wherever you define the CICSPlex, whatever CMAS you were looking at the time you defined it will become the maintenance point CMAS, which is an important thing as we're going to describe a little later on. This is just a list of the different time zones. I wanted to be complete and make sure it was in the presentation. So when you pick the time zone, make sure you pick your own. So you have already 3 or 4 or 5 or 10 or 100, who knows how many regions running. But even though the regions are running, you need to define them to the CICSPlex itself. And this approach is done through top-down and bottom-up definitions, as I'm going to show you. So let's start with top-down. Once you've defined the CICSPlex, what you need to do is define the system names that connect to the CICSPlex. Now, the easiest way to do this is to use the same Apple IDs, so you recognize that. But you don't have to. You can give every region a completely different name than its Apple ID. I personally wouldn't do that, but you could. And again, IBM comes with a starter set of definitions, and you can attach it to existing regions if you wanted to, but all the names would be different. The idea behind a CICS system definition is to tell CICSPlex SM, this is one of the regions that should be connecting to you, and this is the type of stuff you set up in there. And it's about 5 pages long. And so you can see you just need the name to get started, right? What CMAS it'll connect to, right? And then period definition, for example, the time it's expected to be active. So if you're going to use real-time analysis, system availability monitoring, which would notify you when a region is down outside the time it should be down, then you'd have to set up a period definition which says this is the time the region should be up. But you need a couple of things like the Apple ID and system ID then as well, and a couple of other parameters here. Now, a couple things to note. When there's actually a parameter with a pull down and it says the word inherit, it means it's going to inherit it from the CPSM definition itself. So the CICSPlex definition itself has simulated CICS command security checking status that has a value for that, and you're inheriting it from the CICSPlex. Where it's a fill-in box, they didn't want you to have to type the whole word inherit, so you use asterisk. So when you see inherit, 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 asterisk, asterisk, and inherit, I'm basically picking this particular region's definition to inherit everything from the CICSPlex level, right? Now, workload management, if you tend to use this as a routing region like a TOR, or it's an AOR that can do routing, specify routing region active as startup, yes, right? If it's also a target region, you can also use active target region at startup, right? Yes. Now, there's some load health thresholds, queue thresholds. We'll look at some of that a little bit later on. Real-time analysis, whether you want real-time analysis active, yes or no. As I mentioned before, there's some complex stuff you can do with real-time analysis. I would need like days to teach, well, not days, but hours to teach this to you. But I usually set the status at yes, because that will give you at least system availability monitoring. So if you use a period definition and you say when the region is supposed to be active, then that's what it'll use it for. Then if you're using any kind of monitoring, you can collect sample intervals of data. If you use monitoring, the monitoring data is meant to be fed up into real-time analysis. So RTA and monitoring kind of go together. And then finally, whether or not you want to use BAS, notice mine is set to install BAS resources, option never. But BAS install failure, what do? Continue, right? And when you're building this, you can model it after an existing region. You perform create, and it'll create a CICS system definition known as CICSys. So you do this for all the regions in your environment, and you're almost up and running. The problem is now CICSPlex SM recognizes that a region of this name should connect to him, but the region itself doesn't know he's supposed to connect to him. So you need to change your CICS region slightly to connect, and this is the bottom up piece. So you have an existing CICS region. You don't really need to do much with it. CPSM con should be set to LMAS, right? Which is local MAS. There used to be a remote MAS and a local MAS. Now there's only local MASs, but they kept the name as LMAS. And then you might want to adjust max task because you're going to be running these CO transactions and they're long running. They run all day long. Today, max task is usually sufficient in most environments, so I don't worry about it too much. Now, in terms of the CICSPlex SM definitions, you will need an EYU parm, and you will need the CICSPlex SM libraries inside your CICS region. And all you really need is CICSPlex and the name of the CICSPlex you want to connect to. There are some other parameters you can put in EYU parm. If you have multiple CMASs in a single LPAR, you could designate which one to connect to. Some people run multiple CMASs for various different reasons, which I won't go into now. But otherwise, you don't need the CMAS name that you're connecting to. You can also specify the name. If you want to use a different name than your Apple ID to connect, you can specify the name within EYU parm. So these are the notes that go along with it. So if you just read through this, you'll see that CICSPlex SM resources are identified to CICS by updating the CSD. You need the CPSM loader library, SEYU load in RPL, and then some of the stuff we mentioned already. Okay. So let's assume you've built this all and life looks good, right? What might it look like? So let me get into my little WUI here. I'll begin sign on, and then I'm going to put in my password here. Notice that he always pops up an additional window. And the reason for this is, right, is if you take a look up here, I can actually change the URL, and that kind of messes up the navigation. So what IBM does to resolve this is they pop up a new window, which I'll explode to big size. And up here, this is not changeable. So to navigate through this screen, right, you have to actually use the different arrows and the hyperlinks, right? Which makes it less likely to lose the state, right? Because the web is certainly stateless. And you can see my default CMAS context and scope and whatnot. And then here's some general views, and this is the default navigation screens. You can see what you're using. The menu name is down here at the bottom, EYU Start Menu. So what would you use this for? Well, the idea is to use the features of single point of control. I can look at multiple regions at the same time. Single system image. I can actually do a modify command that affects multiple regions at the same time. But sometimes you have lots and lots and lots of regions within your CICSPlex. Maybe you want to organize it by application or break it up a different way, and you can build these things called CICSPlex group definitions or CICSys groups, which allows you to group regions and control them as a group. The point is session control is all maintained through context and scope. And you might have noticed on mine, the context is set here and the scope is set here. When using the WUI, you have an extra one that says CMAS context, which is just the name of the CMAS that you're currently connected to, and that's for administration type commands. So what do you use context and scope for? Well, it's for all the commands that you might issue. If I wanted to look at all the transactions running in my CICSPlex, if I set my context to the CICSPlex and I set my scope to the CICSPlex and I say CEMTI task, it's going to show me all the tasks running in every region in my environment, right? So that's the idea behind single point of control. You issue the command through the WUI. The CMAS has a directory of all the CICS resources. And based on that, he knows where to issue the command. So for example, if I were to issue the command that's equivalent to CEMT inquire tran AB asterisk, and this region here in the middle doesn't have any transactions that start with AB asterisk, the CMAS is clever enough not to issue the CEMT command on your behalf in that region, right? So it's quite efficient in the way it works. Okay? So the idea behind single point of control is, again, to organize and represent resources installed in each MAS. The interfaces include the WUI. You also have an application programming interface, which is basically you can run programs against the CMAS to do things for you. You can also use the CICS Explorer, which I'm going to show you I have up and running. And you can use batch rep, which is like a batch way of doing stuff. And I'm going to show you what I use batch rep for as well. Now, operational views provide the same capabilities as CEMT, as I'm going to show you. Okay. So just as an example, I can click on CICS regions, and because I'm looking at everything in my Plex, I can see all my individual CICS regions, right? If I go backward, I can go down and look at, oh, I don't know, let's look at CICS operations. And under operations, I can say, let me see, I can use transaction operations view, unit of work operations view. Well, let's look at all the units of work in my system, right? CMTIUOW is the example of what I just did, right? So pretty much a lot of the CICS commands are designed so that you can look at it file operations view, right? And then he says, what type of file? Let's look at local files. And here are all the local files in my system, okay? So that's the type of stuff you're doing. You're issuing CEMT commands across multiple CICS systems at the same time. Okay. So again, in terms of the view of the CICSPlex, I can say, show me all the transactions starting ABC. And as I mentioned earlier, if you set your context to the CICSPlex, how do you limit the scope of what you're looking at, right? And so that's why they use the term context and scope. Well, we have the ability to limit that to a CICS group. So you can put a bunch of CICS regions inside of a group and say, CICS group A, right, is these two regions. And if you set the scope to that group name, it will only do the command on these sets of regions. And that scope can be as narrow as a single CICS region, a group of CICS regions, or the entire CICSPlex itself, right? So there you have all the particular options. The context itself can only be set to a CICSPlex name or a CMAS name. And the WUI kind of cheated because he keeps a separate context for the CICSPlex and the CMAS. So if you only have one CMAS, you're never going to change that. And if you only have one CICSPlex, you're never going to change that. So what you're mostly going to change if you only have one CICSPlex and CMAS is the scope. And the scope itself could be the whole CICSPlex. It could be a group of regions or an individual CICS region. There is the ability to use a BAS application scope, but you'd have to be using BAS and you'd have to identify what you call the application scoping of a particular application, right? But it is supported nonetheless. So let's look again at the CICSPlex SM components. So we're going to start with the workload manager, right? The CICS workload manager allows you to divvy up workload and dynamically route it to different regions based on certain criteria, right? We're going to talk about that. Mostly that's what most customers of CICSPlex SM use, right? We have some other features like real-time analysis. It's what I like to call a poor man's monitor, because if you don't have a monitor running, it can alert you to problems within a CICS region. It takes a lot of setup, but then again, a lot of the monitors do too, right? I support a Megamon for CICS, and you have to set up thresholds and situations, and it's very similar. The big difference between a monitor and CICSPlex SM is CICSPlex SM will have to run most of the workload within a CICS region, and some of your monitors do it externally, thereby saving some overhead within the world of CICS. So if you're using RTA, just be careful. You could end up using resources within CICS and impacting the overall running of a CICS environment. Monitoring, or the monitor, is really part of RTA. It's basically the data feed for RTA, where you can collect information about certain things within a CICS environment, and therefore you can make some real-time analysis decisions based on the monitoring. BAS, again, is a newer form of CICS resource definition management at the CICSPlex level. I have to admit, it isn't as popular as people thought it might be, because some of it is quite complicated to do. And certainly over time, it's become, less and less used by many customers. There's a few left in the world that still use BAS. I believe you do, Rob, but.
Yeah, I can interject. We're looking at that paradigm at the moment. But one of the things you mentioned with RTA, I believe IBM have announced that that's functionally stable now, and people should be looking at things like CICS policies or the facilities that a product like a Megamon offers for managing your resources.
Yeah. And what it basically means is they aren't going to add or modify or change it. They probably won't get rid of it because of the customers that are using it, but they won't be adding to it. So it wouldn't be a place to start
Well,
with right now.
it is an amazingly RTA is an amazingly flexible tool, because you can just about monitor anything that you can set up a panel in CPSM for, which is
Correct.
almost infinite. And all the replacement rules that CICS provides, or a third-party monitor applies, don't cover everything that RTA does. So personally, I'm raising a few ideas or RFEs and old money to replace a lot of the RTA things that we have that are very customized to my site. Although some of them are quite general, I think. So plug really, because
make sure you send me a copy of the ideas so I can vote on them for you.
Yeah, I'm looking for the votes. Yeah. Thank you.
You're welcome. So the application programming interface is roll your own, and most people, I would also say this is not one that I would get involved with if you're just starting out today. Like you said, there's lots of tooling today that allow you to do that kind of stuff today. So let's start with workload management. This is the big piece of it. This is what's going to explain all the things that you want to do. But basically, you can come into a TOR, and based on some decision and a routing mechanism, you could route the workload to multiple different AORs. The idea being you get higher availability simply because, if one of the target AORs is down and you're forced normally to run in that AOR, CPSM will route away from problems. If the region gets slow or there's some problem with the region, then he will route the workload to a region that is going to process the workload in his mind faster than it would otherwise run, right? So it's a very simple concept, but it gives you a lot of features. To get started, you'd need something called the workload manager specification, which has the rules for routing incoming work between different CICS regions, right? Now, you'd also need to specify the exits within CICS, the DTR exit and the DSRT exit, to use the EYU9 XLOP program, which is the default routing program for CPSM. And then by setting those two things up, you're already workload management routing to start out. Now, again, this is the simple case. So incoming workload comes into a TOR. Based on that exit mechanism, it's going to route it to particular CICS region. So how does it work? Well, effectively, if you do have the SIT parameter DTR PUGM and DSRT PUGM set to EYU9XLOP, right, then what it's going to do is it's going to use health characteristics of the CICS regions and characteristics that you specify to determine which target region to route the workload to. Now, let me warn you, a lot of customers put this in and they expect to see round robin. That's not how it works, right? It is still an assembler program and a table. And so, for example, if this top region is the first one that always comes back and it's the healthiest, then most of the workload will end up running in that region. It irritates some people to see 80% of the workload in here, 15% of the workload in there, 5% in there. And if you have 3 other regions, they never get any workload, right? If your regions are fast enough to run the workload without any problems, then you're going to see a large percentage of the workload running in one region, right? It's not meant to do round robin. It's meant to send it to the region that is going to process it the quickest. And if multiple regions can do that work, then it's going to send it to the same one pretty much the same time. Now, there's a lot of notes in here. I'm not going to read through it. I'm just going to pass these pages, but this is going to give you some detail about that EYU9 XLOP program. Okay, so how does it work? Well, when the incoming transaction comes in, and depending on whether or not it's a transaction you're running or somebody issues a started task or a DPL. So the DSRT PUGM piece is used for started tasks or DPLs. When you type in a transaction, you're coming in via the web, that's all coming in as a task that will use DTR PUGM. So that exit, when it's invoked, is going to read the rules that you provide as well as the health info. And based on that, it's going to determine which CICS region to start the work on. Now, it's going to use the workload manager data space controlled by the ESSSS to have a look-see to see which region appears to be the healthiest for you to run in. And that's how it works. And again, this will go through the notes. Now, there is some mention at the bottom here. Optionally, we have CICSPlex optimized workload management that can be used since CICSTS version 4, right? Which will help when you're trying to optimize workload across LPARs. They happen to notice that obviously when we're routing workload, what we're probably going to try and do is route the workload locally mostly. And we're not going to consider regions that we have on another LPAR simply because the transmission time and the type of connections that you might have in place will make it less likely that the workload will be routed there. So IBM invented the concept of CICSPlex optimized workloads, which will do a better job of shipping workload between LPARs. And you could read through this. It shows you how to set the individual parameters, right? The load value, how many counts there are, right? And whether or not you should use optimized workload. Keep in mind, internally within CICS, he uses a region status server, which is basically a different domain internally within CICS. And the server itself started in the same ZOS image as the CICS regions to try and do a better job of determining whether or not there's a region on another LPAR that would do a better job of processing the workload than locally. Okay, so this is where everybody starts to throw up, right? Because they say to themselves, oh my God, what do I need? Oh, this is crazy, right? So the first thing to point out is in the world of CICSPlex SM, there's a difference between how definitions are linked together. In a CSD, when you create a transaction, right, and you tell it what group it lives in, if the group doesn't exist, it creates the group. If you delete every definition from a group, the group automatically deletes. In the world of CPSM, you can create a definition. So you see workload manager specification, group, definition, tran group. These are the entities. And then you could see add to group, add to spec. These are the associator records. So you can actually build a group in CPSM that has nothing in it. And it's not related to anything. It's just floating out in the middle of nowhere. In order to add a workload manager definition to a group, you have to create that association, and that associator record is separate from the group record. So once you get used to this, it becomes relatively simple. The second thing to point out is if you're willing to route workload from anywhere to anywhere, then all you ever need is one workload manager specification and you're done. When would you need a group and a definition? We're going to see is when you have exceptions to the rule. So normally I want to route any workload from anywhere to anywhere, but you know what? This one application has to run in this AOR. Then what I'm going to do is identify those transactions associated with that application and build a definition that says for those transactions, no, it doesn't run absolutely anywhere. It only runs in one of these AORs. Yeah. So if you have no exceptions to the rule, you'll only have a workload manager specification. If you have exceptions to the rule, then you'll create definitions, you'll group them together and associate the definitions to a group, and eventually associate that group to specifications. So let's talk about exceptions in just a second, but first let's show you a specification. So here's me creating a specification, workload manager, and it have to be under the workload manager administration views. And effectively, what do you do in a specification? You really basically identify the target, right? So what we're going to see is we create a specification. The specification in my case says, I have no affinities, I have no search criteria. Effectively, I'm saying for the specification called test one, he says, send the workload to any one of these 6 AORs. Who cares? Yeah. And then I perform the create. I also have to choose the algorithm type to use the workload manager goal mode or just the queue algorithm, which is kind of round robin if he has to. And then what I'll do, here's the notes. And then what I'll do is I'll associate that specification with the TOR or TORs that I want to follow the rule. And so therefore the TOR looks at that specification, has a list of AORs that it can run workload in, right? So what are exceptions to the rule? That should be your first question, right? And by the way, I'm going to use the Explorer for this one, but let me just jump to this quickly, right? So here's the Explorer. looking at all the KICS regions in my environment. But now what I'm going to do is in the Explorer itself, you can find it, there's a separate CICSPlex SM management structure here, right? And within here, I could take a look at workload management, and you can see there's my specification. If I click the specification, I can actually pull it up. So there's the specification itself. Let me close that for a minute, right? And this specification, if I open it, oh, let me open it again, sorry. You can see the AORs that I would route it to, right? And then the specification itself is associated with my Plex, and it's mostly, if you look at the routers, it's associated with my TOR. And in terms of routing rules, it's using default routing. So I have a specification called this. It only works with my one TOR, which is over there, right? And the routing rules will separate it out to send it out to specific AORs, right? And I have a bunch of regions here, and these are the two AORs that it's going to actually send it off to, right? And how do I know it's sending it off? Because I'll look at my system groups, and in there I have FUW AORs, and in there I have my two AORs. And that is where you saw earlier that this specification picked as a target. So it says anything coming in through that TOR will go off to those two AORs, and that's the bottom line. But now let's talk about exceptions to the rule. Exceptions to the rule deal with things like affinities and separation. Transaction affinities, which cause you to run a particular workload in a specific region. And then the separation is basically saying, I don't want these transactions running with those. In order to do that, you're going to build a workload manager definition and associated with a group. The definition is going to have a transaction group to specify which transactions fault or come within those specifications. Okay, and there's the notes. So here's me creating a workload manager definition. The tran group I'm going to use is tran group 1, and it's going to use my user ID, RSMIS1, to separate the workload out to a target region called MAS9. Okay. Now, that was just me doing workload separation. What about affinities? Well, there's a whole complex discussion on affinities. There's an affinity relation and how long the affinity should last. So there you go. A particular user ID could be a relation, and it could be a system-related affinity or a permanent affinity. Okay. Now, the notes are all here, so you could read through what the various options are, right? But here's an example of me creating a group definition, right? And in terms of the group definition, this is going to house a bunch of transactions, and you can see the transaction that it's going to, how is it going to separate out the workload? It's going to use an affinity lifetime of pseudo conversation. So it's going to maintain an affinity for a pseudo conversation. And I can actually specify tran 1, 2, 3, and 4 as part of my conversation. And then as long as a user starts with one of those 4 transactions, or if I tell him the transaction that starts as tran 1 and the transaction that ends as tran 4, then he'll route the first transaction to any one of my AORs. But for the same user ID, he'll route 2 and 3 and 4 to the same region. So that's a pseudo conversational related affinity. That's just an example. And this is just to show you can do the same stuff with the CICS Explorer. What I like more about the CICS Explorer itself is you can actually select the transaction group, and then you can pick out transactions from here, and it'll put it in a table there, which it makes it a lot easier to do than typing out 100 different transaction IDs, right? I could say D asterisk here and then select them all, right? So it makes it easier to build transaction groups using the CICS Explorer. So real-time analysis, as you said, it's functionally stabilized, but just as a brief overview of how it works, right? It basically collects samples and it evaluates stuff that occurs within those regions, and it has the ability to produce events, send messages or alerts. Okay. Now, there's some notes here that you can read through. And then for monitoring, this is collecting the data into data spaces. And like I said, in terms of monitoring, it collects the data used by RTA. There are separate monitor specification that you can specify, and there are up to 10 classes of data that you can look to collect data on to make decisions. In terms of BAS, right, gives you the ability to create resource definitions. Again, if you haven't done this yet, it's not a good idea to get started. So just to give you an idea of how this worked is the definition would live in CICSPlex SM, and you could associate that definition to multiple CICS regions. The idea was to create like a super file. Your DREP would contain all the definitions for multiple CICS regions. And then there were various different ways to install it. There were basic BAS and fully functioning BAS, right? And based on how you'd want to run it, right? You could have different resource definitions installed with different attributes in different regions, right? So again, in terms of BAS, you could separate it out by BAS application scoping and decide what gets installed into what particular CICS region. And without getting too ugly, right? Remember in the CSD, you define a transaction in a group, it automatically creates the group definition. You define the transaction and put it in a list, it automatically creates the list definition. With BAS, it was different. You created the resources, you created the groups, and you associated them together. And then you chose how you wanted it to be installed in a CICS region using the res desk or resource assignment def, right, which are fairly complicated to learn in under an hour, but nonetheless, you had ways of installing it into a CICS environment. Okay. Good. Questions so far? So the last bit of this we'll talk about is batch rep, right? The batch repository facility, which I tend to use to kind of dump what's in the EYU DREP, and then mention a little bit about the web user interface in the CICS Explorer, although you've seen a little bit of it throughout the presentation. So the idea behind batch rep was the ability to run what they thought was a batch job, right, within the CMAS. But the way they built it was you put some data in a data set, right, and member, and then basically you logged on through the WUI and you executed it, right? So it wasn't really like a batch job, right? It was, you know, here's your data set member, it contains commands, and you perform execute and it'll execute it, right? So here's a sample of my input data set, right? You see the data set name and member, and in here, you indicated where you wanted the output to go, right? Output data set and member. You set a context because everything works from a context. And you can see this was dump the CICSPlex definition and then set another context and dump a CICS system definition. So that's what I wanted to do, right? Now, that was all really nice, but you'd have to go in and do the run, and it was a pain in the neck. And IBM said, oh, we could do a better job of this. We'll create a real batch job, right? It runs a program called EYU9 XDBC, which kind of works the same way, but the difference is within here, instead of specifying and logging on to the WUI and putting this data in here, you could put it in the batch job. So there's the CMAS name. We want to execute. There's the input member and data set name. There's the output user ID and the print node, right? So this is effectively like that first screen. You'd still need a data set and member with the commands you want to execute. Now, whenever you'd run this, you'd notice that if you actually went to the job itself, right, and you'd go to the CMAS, right, because remember, this is all executing in the CMAS, you put a question mark next to it, you'd see all these members called S and then a unique number. And that was for all the batch rep runs that you would do. And it would show you the results of whether or not it worked. Not only that, but if you had an output data set, it would dump the CICSPlex definition as I just did. Now, why would you want to dump a CICSPlex definition? Maybe you want to back up the data repository. So this was quite a nice way to back up the data repository. Anything that was set dynamically, right, like the change agent and create time, it would still dump it, But what it would do is put an asterisk in front of it, because you can then use this as input to create a new EYU rep. Yeah, and that's just the kick system definition. So what I used to use batch rep for is to dump or back up my entire drep if I wanted to move it somewhere or change it or create something different. So I'd set my context to the CICSPlex name. I would dump my workload management stuff. So this is all workload management stuff, right? As well as all my Kix systems and my CICSPlex name. And life was good. I had a backup of everything I needed. Okay. Now, you've already seen a little bit about the Kix Explorer. Again, it's still, the Kix Explorer is still heavily used. And this is what I was using over here when I was doing the Explorer stuff. I went into the SM management interface, but if you go into the SM interface, you can see there's my CICSPlex, there's my individual regions. If I click on the CICSPlex, it'll show me all my regions. If I click on an individual region, I can work with an individual region, right? And then I can actually click on one of my groups, my AORs, and see my AORs as a separate group. If I wanted to, I could click on tasks. It'll show me all the tasks running across my entire CICSPlex, right? I can add or remove any of the tabs that I might want to. So under operations, I click this tab and I can say MQ, I can say dumps. Let's look at system dumps across my entire environment. And I can look at any of the system dumps I've taken across my entire environment. And you can see dumps since startup, I don't have any specified here. So I didn't take any dumps, yeah. And then you could customize the columns in here. So it's very flexible to use the Kix Explorer. Okay. The WUI I kind of showed you as well. It's lightweight because there's nothing to install on your PC. You can just run a web interface and you can click on things like Kix regions, right? And you can do sort of the same sort of things, but it's all based on HTML pages, right? So if I wanted to, I can go back to the homepage for a minute. I'll go into operations, right? And then you can do application operations view, file operations view. The one thing I'll warn you is anything that comes out new will not be added to the WUI. It's functionally stabilized, right? But the Kix Explorer has the ability to set policies and build some of the new platforms and applications if you wanted to do sort of that type of stuff. There's the transaction operations view. I can look at transaction monitoring. I can look at local and dynamic transactions. And of course, I'm above the 2000 threshold, which I set as a warning. So he says, do something like C asterisk, right? Click OK. And then as a subset, it'll show me all the C transactions, right? To limit the views that are being taken. So that is the WUI. Okay. So again, it's relatively easy to set up CICSPlex SM. It's a good thing to have, just simply to be able to operate over multiple regions at the same time. You can actually set up the Kix Explorer to talk to one region at a time, but then you have to keep disconnecting and reconnecting with a WUI. You're connected to all your regions at the same time. So it's fun. It's easy to get started. And again, just a couple regions to set up, and you can start playing with things like workload management or looking at all your regions at the same time. So now I'll open it up and see if there are any questions. Let me look at the chat.
Me talking on mute. Nothing in the chat as well.
Okay, good. Well, again, if you have any additional questions you think of down the road, feel free to send me an email. My email's on the first or second page of the presentation. But otherwise, enjoy your evening. Thank you, Rob.
Thank you very much, Ezra. And we look forward to seeing you again soon.
Absolutely.
And thank you to everyone who's attended all the sessions. This is the last one for Kix. Look forward to the next conference, which will be a face-to-face near the end of the year in November. Can't remember the exact dates, but it's early November, around about Guy Fawkes. And thank you very much for your attendance. I think there's an IBM Kicks community event in Edinburgh in June. Don't know if you've had everything for that, but that's probably the next one on the radar. Thank you very much, everyone, and keep safe. Cheers.
Thanks. Cheers.
Thank you.
Thanks. Bye.
Bye.